don't know which one caused the deadlock one. Okay? Instead, we are going to consider something criteria. Okay? So our goal is to minimize the cost. However, the cost means depends. It depends on the criteria. So cost can be considered as a specific resource type, mostly CPU. However, it can be considered as the something priority. That is the overall cost. Okay. However, if we have applied a certain criteria, sometimes the certain process can be always a victim if it has the lower priority. Okay, so you need to consider any the priority-based algorithm has the same problem, that is a starvation. So how can we address the starvation problem? The naive solution is aging. Okay, if one process is killed as a victim, next time assign higher the priority. Next time higher. If the killed again and higher, something like that. That is the aging. Depending on along the time you give the promotion. Usually, most of our operating system, okay, combine any of this. So not always the prevention or the not always avoidance, but mostly prevention and avoidance. Either not prevention, avoidance, and detection. They are basically using the same algorithm, which is based on the graph theory. Some of the students may be curious why Professor Lee skipped this one. Complexity in terms of bigger notation is n times n squared, okay? Which means it's totally depend on number of process. 2 process, 3 process, a number of process. And even square, because for each loop you need to check the, and also multiply by, it depends on the number of resources. It's huge, okay? In other words, it's very, very expensive to run such a graph algorithm. For example, what is that? The banker's algorithm, safety detection algorithm. It's very, very expensive. So nowadays, most of the modern operating system ignore this, the deadlock. If they just ignore the deadlock, okay, then in case the deadlock situation, application program so is in charge of that. However, still operating system use such a basic approach, it depending on the purpose of the objective of the operating system.
Can you
Yes.
define the prevention again?
Prevention, so last quick summary. Prevention means we have 4 requirements, right? Okay? The 4 requirements. What is that? Mutual exclusion, hold and wait, and no preemption, and circular wait. Why don't we break one of the requirements? Right? We may not enter the deadlock situation. But sometimes it's not possible. So avoidance, we are not going to enter deadlock. How? Whenever we have the request, we need to check whether this request caused the deadlock one. How? Using the banker's algorithm. Detection allow, but periodically check whether there exists deadlock one. So we can use a combined of this basic research. But nowadays, the operating system trend, because this prevention sometimes not possible, and avoidance and detection is very, very expensive. Even though they are optimized, the graph theory algorithm still very expensive. So many of the operating system ignore such a deadlock. However, depending on the objective of our operating system, some of the operating system is critical. Like you have the operating system to detect the nuclear plant, the problem. Okay. At that time, if you ignore the deadlock, the alarming system will be stopped because of a deadlock. So you need to, even though that is expensive, you need to do something. So at that time, we can use such a algorithm. So actually, I skipped some part of the algorithm. Example of the algorithm basically is the same thing as the banker's algorithm, but I strongly suggest I'm not going to assign the homework but I strongly suggest to the practice by yourself. Okay. Also, do not try to understand the algorithm based on the PPT file only. Okay. I don't think you can easily understand. Why don't you read the text? That is the best way. Okay. Any question before we move to the next? You want to continue the next chapter? So we have the 15-20 minutes. So during that time, GA will the handout your midterm exam sheet and check your midterm grading. Okay. So then, if you have any problem, so I try to my best to grade both the operating system database correctly, but it was really hard, tough to grade the 60 the exam paper and the database is a 50 paper. So in case there's something mistake, you don't have to argue or anything. Just mark on the front page. The question 1 is wrong, or if you are not clear my grading, so then mark the why don't you regrade the question 1 or question 2, something like that. Okay.
So, and how are you going to?
This is just the statistics of your midterm exam. So definitely, depending on considering your overall performance, I'm going to apply the curve separately for graduate student and undergraduate student. But I don't decide yet how much curve will be applied. I'd like to see the overall performance of the throughout the semester. Then when I decide the final grade, I will apply the curve separately. But mostly I'm focusing on the average to the around the 7. Okay. Any question? Okay, so write the hand down and
you guys can come 101, so I can give you the
this is sorted by the last name.
last name.